Hello viewers, Alan here. Welcome back to my workshop. It's been a few weeks, hasn't it? It's been, I think, over a couple of months since I put my last project up. I won't go into a whole lot of detail. Let's just say I'm 70, some bits don't work as well as they used to. And what was slowing me down this time was my feet, peripheral neuropathy. Anyway, I've been back out in the workshop for a week or so now and started on a new project. And this strange looking yellow thing here might be a clue. I'll swing it round. What is it, you might ask? Well, it's meant to be a drill grinding jig, which was originally sold as an accessory for the AR tool and cutter grinder that I've got. I don't have one, so I decided to make one. And I don't have drawings, or I didn't have any drawings, so I just worked from some photos, and a couple of viewers sent me some dimensions of theirs, and I slowly put it together. It took a long time, and I had to rediscover some stuff that I'd forgotten about from uni, matrix transformations and vector maths, but because there are compound angles here that were really slowing me down trying to work out how to model this thing. Anyway, let's just dive in and start making some chips, and I'll explain more as we go along. So I'm going to start by making the V blocks that the drill will sit in. This is 32 that way, 52 that way. To create some material suitable for making those, I've got some 76 diameter piston rod here. So this is the stuff that's chrome plated on the outside and induction hardened. So you need to strip all that off before you can start doing reasonable machining. So I'm going to strip a lot of that off and then take it over to the milling machine so I can make some square section stock. I think the tip might have just given up the ghost there. That's pretty tough stuff. And it did remove quite a bit of it on that corner. You don't touch that stuff with bare hands. So once you pass the hard chrome layer, the cutter holds up a lot better. Well, that cleaned up very nicely. This is the piece I won't be using for this job, but since I'm making a big mess stripping this hard stuff off, I thought I might as well do the whole length. Yeah, so I was aiming for 72. Just an arbitrary size to put it in the rack as a piece of bar stock. Alright, so now it's time to turn it round and machine this piece down. So with the hard outer layer stripped off, I can get on with reducing the diameter down to 62 millimeters, from which I can create the bar stock that I want. Well, that worked pretty well with a 2 millimeter depth of cut, but the chips weren't breaking quite as well as I would have liked. So for the next pass, I think I'll kick the feed speed up one notch and see if that encourages the chips to break. Well, that works beautifully. The chips are breaking really nicely, and I think my next pass will be down to size. So after that pass, we're sitting on a diameter of 64. I want 62 because that's the diameter I can get the cross section of my square bar out of. But 62 is approximate, and I think maths show I actually want 61.06. But the milling machine will bring it to size, so I'm not worried about being exactly on 62 here. The turning I've done so far was done at 380 RPM, but the diameter's come down a little bit now, so I might try my arm at the next speed up, which for me is 560. Not happy with those stringy chips, so I think I'll take the feed up a notch. Still had stringy chips, but anyway, we got there. So hopefully that's somewhere near 62. Yeah, that's close enough. So I've lopped a piece of that round bar off, long enough to make my two sort of V-block shaped pieces from. So time to put that in the vise and square it up. So I had a bit of thought of the best way to machine the material off this. I have to come down 15 from the top, so it's quite a lot of material to come off. Decided to use this cutter, which is I think it's 5 inserts, and rightly or wrongly my thinking is that the cutters will be able to ramp up on the amount of material if I'm coming this direction and do the reverse on the other side. Bit of experimentation, we'll see what happens. We'll certainly have plenty of fireworks there, but the cutter did a pretty good job, so I'll come back on the other side and move the camera to a safe distance too. Well, I'm getting sprayed with hot crap here. I have to rejig something. Don't want the camera getting sprayed either. So I set up the cut differently, and now I'm taking a 3mm depth of cut across the full width of the face. That seems to work a lot better, as you can see. So this should be the finishing pass for this side. I came down in 3mm thick layers in the end. That seemed to be the best compromise. And on this final pass I'm taking a depth of cut of 0.2mm. Well, that left a pretty good finish, and we're right on size. I think we're actually 0.01 over, but anyway, that's on size. So we've got to flip it over and do the other 3 sides. This cutter does put on an impressive fireworks display though. So after looking at the pattern the cutter left and thinking about the fireworks, it finally dawned on me that the issue was really not so much the toughness of the material, but that the inserts were knackered. So I've got a new set of inserts and it's a different story. So this will be the final pass here. I've only got 0.06 depth of cut, 0.07 depth of cut. It's final cleanup. So those fresh inserts made a big difference. Should have woken up to the issue much sooner. You get focused on various things and sometimes don't see the wood for the trees. Anyway, moving on. So I'll try out this second-hand cutter that I picked up, machining the other sides of this block and see how it goes. I think it will probably do alright. So I'm certainly not going to complain about that cut or the surface finish. That was a 2mm depth of cut. I'll do another 2mm deep cut, which should bring us to full width, and see how we're going. I might need a check measure at that point. Actually, since that was cutting so well, I'm going to increase the depth of this cut to 2.5mm, which will leave a 0.5mm final pass to get to size and take a thin cut for a good finish. So after all that milling, I have my block with correct width and thickness, as you can see from the pics. I haven't yet decided exactly how I'm going to machine the V, which is the next piece, but I know I need a centre line at least, so I'm going to start by scratching one of those in. So we use the centre finder to do that. So now I'm going to scribe a centre line using the point from my scriber mounted in a collet. Now I haven't tried to do this before, so I don't know whether it's a good idea or a bad idea. We'll find out. Well, I think you can see that actually worked quite well. So I've decided that to cut this V in the block, I'm going to mount the block in a sine vise, and using a stack here underneath the pivot point, I've got this set to 39 degrees, which is the correct complement to allow me to get the 51 degrees, which is half the included angle here. So I think you'll be able to see that as I swipe the vise across the DTI, that the vise is now set up true to the x-axis. That's to say the jaws are perpendicular or normal to the x-axis. As a final alignment check, I've clamped a ground parallel here, and that creates a true corner which I can run the edge finder against, because the top corner of the block has been deburred and etc. it's not a true to a point 90 degrees, whereas this is apart from a very minor chamfer, you can hardly see it, it is true. And what the edge finder from what revealed one end to the other is a 0.02 variation, or about 1/1000 of an inch, and I'm not going to bother to chase that. So now, knowing the dimensions of this ground parallel, I can infer exactly where the corner would be if it was still there, and use that as the datum to do the milling operation. So having found that front edge there, I've done a bit more shop maths to work out the infeed and rise to get my V shape. I spend enough time messing around with this, it's time to make chips and hope for the best. Well, there's a lot of material to take out, but that's a start. I'll bring you back when I've made a bit more progress. So I've been gnawing away at this. As you'll remember, I started out with this cutter, but the inserts have quite a positive rake on them, and they're really not meant for really heavy duty cutting like this, I don't think. So I changed over to the 75mm cutter, which has much heavier duty inserts. There's a lot more body to them. Anyway, so we'll press on. I'm using 1.75 depth of cut passes after a bit of experimentation. Okay, well that's one side roughed down nearly to size. So we'll have a big clean up. I've got a mountain of chips here. So I've had a big clean up, turned the block round in the vise, and I'm going to start taking cuts on the other side of the V to get the angle on that side correct. Well, that seemed to work out alright. It looks like a V block, doesn't it? So it looks like my math was correct in working out where to put the offset in from the side. A couple more passes at the same setting on both sides just to clean it up, and we'll be done. Okay, so that's my V block with a 102 degree included angle. The first of several really tricky angles I've got to cut on this job. I don't know whether you'll be able to see this, but perhaps if I hold the perhaps if I hold it like that, you get the idea. As far as I can tell, I'm spot on 102. In any case, that's as close as I'm going to get. So the V block looks pretty good, but I thought it was a good idea to check whether the V groove was actually tracking parallel to the base. So I have a 16mm dowel pin in here. We'll just see what we get here. Looks like we're on 31.212. So I'll turn it round in the vise and see what the other end reads. Turn the dowel pin around as well. 31.212. What have we got here? 31.222. So we've got 0.01 difference from one end to the other, or less than, what's that, about 0.6 of a thou or something. So pretty happy with that. So moving on, I need to explain a little bit. The piece that I've been working on is the front drill rest, that's this block here, and it's going to be attached to the top plate with 3 screws. So then I have to work out how to drill that 3-hole pattern in the block and in the plate, and they'll be done separately because I don't see any way to hold them together to drill through. So I need 3 4mm holes in here with countersink and 3 tapped holes here. So just looking a bit more closely at this top piece, you can see there's there's an indexing tab or projection on the bottom here, and its purpose is to align the front and rear drill rests in using this groove in the top plate. So I've already milled the reliefs on the side of the underneath of the front drill rest. The question now is how to position these holes. So I've decided to make the top plate out of aluminium, because it's 16mm thick, so there's a bit of weight in it. And the method I'm going to use for locating the holes, this drawing's a bit busy, but I've established basically the front edge of the billet for the top plate as my datum, and the front edge of the front drill rest is out beyond that. It's out beyond it by 10.22. So I can drill the 3-hole pattern in the top plate, working from that line, and 5mm each side of centre, and the hole pattern into the front drill rest needs to be offset by 10.22, and the dimensions calculated like that. So I don't know whether any of that makes sense. Hopefully it does. So anyway, let's drill some holes and pray that I haven't confused myself and everybody else. I use these 2-point drills for this sort of thing to get started, because they're short and quite rigid. They run out of depth there. So we go back in with correct size for tapping, 3.3. So getting set up for tapping my M4 holes. This tap has a point on the top, so I've turned the tap follower end round to have the divot that will locate on that. And we get a bit of goop on the tap and start winding him in. So that's my 3-hole pattern, and I did show it to the plastic sample. You won't be able to see it, but the hole pattern does line up correctly. Very encouraging. That's as far as I want to take this piece at the moment. What's left to do is chop it off to length, and the piece that gets chopped off will be the rear drill rest. But the major piece left to do is cutting the angled planes on the front here, the compound angles. I don't know how I'm going to do that yet, so I'll leave that and switch my attention to making the top plate. This guy is 425 long and at the widest point just over 78 wide. And there's a few operations to do. I've got to cut this groove both sides. I've got this 16-degree angle piece to do, and another groove parallel to that 16-degree angle. The 3 holes, of course. And cut this big piece out. I think I already said that I decided to use aluminium for weight saving. But because of all these operations, I can't really think of a way of holding it, holding the work, holding the stock, so I can do all the operations in a single setup. It's just not going to happen. And my first thought was to mount it in a couple of vices to clean the edges up, and I think that's a waste of time. I shouldn't have done that. It's a bit like to a hammer everything's a nail. Because the sine vise was sitting on the milling table, I thought, oh, I'll just mount it next to the other one, and yes, it sort of works. I used the digital height gauge to check the difference in height of the floors of the 2 vices, and the shim to, etc, etc. But realistically, I don't think it's a very useful way to do things, because it doesn't allow me to do this grooving or whatever else. So I'm going to rip the vices off the table and find a way of just mounting this block, this stock, directly on the table. So I'll bring you back when I've worked out how to do that. So with this setup, I'll be able to do all of one side in a single pass, and then without slackening off the clamps on each end, switch the middle brace over to this side and then do the cut on the other side. and at least then I'll finish up with the two long sides parallel. And I don't know what I'm going to do next when I get that far. I think that cut came out pretty good. So probably the longest single cut I've ever done on this machine, I think. So now I'll clean up and switch this clamp to this side and repeat on the other side. So I think this setup will allow me to move on to the next stage, which is cutting a 20mm wide, 3mm deep channel on both sides of this workpiece. I've decided to leave the big cutout on one side for the time being and focus on the detailed pieces. The cutout is a bit of a dress up, I suppose. It's not actually have any critical dimensions, so I'll do that last. Anyway, let's see how we go with the 20mm cutter. I'll be using flood coolant for this long cut, and hopefully I won't get sprayed too badly with coolant. Well, it certainly made lots of chips. Time for a big cleanup. So I've cut the 20mm wide channel, and the cutter has left quite sharp corners on the top surface here, which is to be expected. And the shoulders, the recessed shoulders that I cut on the block here, have a radius in this corner, which would foul on that corner, top corner. So I'm going to use this chamfering tool to knock that corner off both sides. So with both top corners chamfered, this guy will now go in there really nicely. Doesn't move at all, side to side. You can slide it, but it's not real happy about it. So it's the perfect fit for indexing on that projection into the groove. So with the channel in the top surface of the top plate finished, I'm going to now drill the 3-hole pattern for mounting the front drill rest onto that top plate. I wasn't able to spot through those holes, so this is all by calculated dimensions and on my drawing. So fingers crossed. I'll drill the holes at the absolute minimum size. That's the outside diameter of a threaded screw. For a 4mm screw, that's about 3.9, something like that. So that does give me some limited little opportunity, if necessary, to move the hole slightly with a 4mm end mill. So I've switched over to a number 22 drill to open the holes out. So hopefully that's 3 holes in the right place and to suit that, but I won't find that out until I pull this fixture apart. Moving on now to making the slots in the top plate. There are 3 of those slots. They're each 105mm long, and they're separated by a couple of lands that are 16mm long. Width of the slot is 10mm, but that's fairly nominal. Its purpose is to allow a bolt to slide backwards and forwards along, and provided the bolt can clear the slot, that's all that's required. I'm planning to use a 10mm bolt. I might even use 8, but it doesn't really matter. So to form the slots, I'm going to drill a hole at each end of the slot and then join the dots with a 10mm end mill. So I'm going to drill using a V-letter drill, which is slightly undersized on 10mm. So that should mean when the end mill gets to each end of the slot, it'll just clean up nicely. Well, that's the plan. Let's see how it works out. So that's finished the cutting. I did have a little bit of a drama though, not with the cutting, but this stuff here was clogging the drain on the end of the milling table and causing the coolant to back up. And that caused a brief moment of panic. Certainly need a big clean-up. So with those slots done, I think there's only one more thing to do that requires a bit of precision location. There needs to be a slot here that runs at 16 degrees to this line here. And positioning the start and end of the slot is difficult when all of my datums are on the XY plane for this thing. So what I decided to do was drill a hole at the start of the 16-degree slot, and that would give me a new datum point to continue with when I've got this lot rotated at 16 degrees. At least I know where to start, and I only have to worry about how long to run the slot. So perhaps this might help make sense of that. So obviously I've just done the 3 long slots, and I've worked out from the geometry where that hole needs to be in relation to that corner. And oh, come in. Sorry about that. My most important other 3/4 just popped head around the door. So I think picking up from where I left off, locating this slot here, I need to have I'll use that hole as a start point. So I've calculated the XY offsets for that, and I'll drill it slightly under 8mm and then ream it to, or use an end mill to accurately make it 8mm, and then I'll be able to put a dowel pin in there to find that point for doing the rest of it when I've got this thing oriented correctly. Right, time for the last cleanup for this setup. So I'm pleased to report that with the V-block snugged into its groove, these screws do in fact all line up. And I would say they line up perfectly. They all run in with no binding at all. That's my first sub-assembly. But this block is a little bit firmer in its groove than I'd wanted it to be. But I think it'll be alright. So a new setup with the top plate set at 16 degrees to the x-axis. That was achieved by putting a 16-degree stack of angle blocks in here. And this setup will let me cut the other channel which is required in the underside of the top plate. It's 14mm wide, and it will have a mini slot in it as well, made with an 8mm cutter and 16mm long. So using the datum hole, which I established before I broke the other setup down, I can set my origin point on that hole with an 8mm dowel. That dowel is quite a close fit in the hole, and it's only done up loosely in the collet chuck. So pretty happy that I'm on the mark there. That won't fall in there. That was a very precise alignment. So I've set up my little scriber again, and I'm going to use it to make an index mark, just to give me something to measure to. So perhaps you can see the mark, if it's in the right place. It'll be 40 from this back edge. And to my old eyes, I don't know how well you can see that and how well the camera's picking it up, but that's spot on 40 as far as I can tell. So happy with that. That was a good reassuring measure. So I'll extend that line across the full length of the future cut. So that's given me a pretty good line to work to. So I've changed the battle plan, and I've decided the next thing I'm going to do is cut that back corner off. That's a 16-degree cut. I'm going to use a 10mm end mill and try my luck doing it in 2 passes with an 8mm depth of cut on each pass. And I've set the cutter to be 0.2mm short of the final dimension, so that I'll be able to do a final clean-up pass, 2mm depth of cut. Not sure whether this is going to work. Not sure how happy the end mill is going to be with an 8mm depth of cut, but I guess we'll find out. So that worked really well. Very pleased with that. So I'll have a clean up and then come back for the second pass. So the cut's over halfway now, and I stopped it to put a clamp across the cut so that the piece that's being cut off can't disappear into somewhere dangerous. Well, that's the plan anyway. It looks like my offcut catcher worked. So that's the offcut, and as you can see, the cutter did an excellent job. So when I made the V-block, I made it long enough for both the front drill rest at 52mm long and the rear drill rest at 25mm. So now it's time to cut it into the two pieces. So this is where the cooling system that I added to the bandsaw will really pay for itself. 4140 is pretty tough stuff, and keeping the blade cool and lubricated will extend its life a lot. So now I'll clean up that cut face and bring the front V-block to its correct length of 52mm. So I've given this thing a quick deburring and it's come out pretty much on size. Right, well I think I'm going to stop here for now. I've finished most of the top plate, all of the hard stuff, laying it out, and various bits. So I've got the grooves and slots all done, and the front drill rest and the rear drill rest made and bolted. They all fitted and aligned correctly, so I was very pleased with that. The next piece to tackle, which is an unknown for me at the moment, I don't know how I'm going to do it, is on the end here, which you can see on the model. There are two compound angles that have to meet on the centre line here, and I don't yet know how I'm going to do that. And then also another trench here for this indexing plate to fit into. So that's the challenge for me in the next video. But I'm pleased with how this has worked out so far, at least. So if you're finding the project interesting, please join me in the next one and we'll tackle some of these compound angles. Thanks for watching. Cheers.